So we start to move. See my screen?
Yes, sir.
Yes, please.
Okay, I'm doing the recording, so please stop asking me to record personally. Other than you strain the system. Okay. So this lecture is fundamentals of big data, and for our first set of lectures, we'll look at the concepts that are related to big data and beyond. Oh, a minute, just a minute. I revised this one. Hold on. Okay. That's it. That's it. I think I put it here. Okay. So, like I said, we'll deal with the concepts of big data. We'll deal with the concepts of big data generally. So here we'll look at the core concepts, the big data environment, the sort of things that are within the environment. And then we'll look at the life cycles of big data initiatives, okay? But as part of it, one of the central things which we'll do in there is the hands-on aspect is relational databases, right? We deal with relational databases and we deal with non-relational databases. These two databases forms the heart of big data environments. Okay, great. But there is more than that. There's other huge technologies which these databases, among others, in large quantities rely on. Now, why big data? Let me ask, what is big data? Anybody? Let's have a discussion first. What is big data? Hello, guys. What is big data? I'm listening. Hello. I'm waiting for you guys.
Yeah, what's up?
I'm good, what's up?
I'm good, sir.
Nehemiah, you can talk to somebody, but not to my question. What is big data, guys? So you guys are doing analytics, so you read. So go ahead.
A very large data set.
A very large data set.
Yes.
Okay. Who else again? Anybody else? I'll call
Yes, sir. Please, big data refers to a large amount of data that arrives in increasing volumes when it has, with faster speeds.
It arrives in large volumes and with faster speeds. Okay. That's interesting. Okay. All right. Thank you very much for that. That's interesting to note. Okay. All right. Sadika, are you back?
You stop.
Okay, so Sadika, just introduce yourself. So please, everybody, Sadika, like I said, will be taking you for tutorials. So can you say a word or two, Sadika?
Okay, I'm Sadeka and I'm currently doing my MPhil Management Information Systems. I hold a master's degree in Business and Data Analytics. I've been exploring artificial intelligence in health insurance claims adjudication, which formed a major interest in my master's thesis. I'm currently exploring generative AI in legal research, which is the current focus of my MPhil thesis. That is all about me.
Okay, thank you very
Sadeka,
much.
what are your pronouns?
What are what?
Hey,
My
Jenny,
ma-
I am Boko.
Okay, guys, please. So Sadika will be with us. Please, nobody should worry her. She's just
yes.
there for your tutorials. Don't worry her. Okay.
Right, thank you.
Thank you very much, Sadika.
You're welcome, Doc.
Okay.
We all use smartphones, but have you ever wondered how much data it generates in the form of texts, phone calls, emails, photos, videos, searches, and music? Approximately 40 exabytes of data gets generated every month by a single smartphone user. Now, imagine this number multiplied by 5 billion smartphone users. That's a lot for our mind to even process, isn't it? In fact, this amount of data is quite a lot for traditional computing systems to handle. And this massive amount of data is what we term as big data. Let's have a look at the data generated per minute on the internet. 2.1 million snaps are shared on Snapchat. 3.8 million search queries are made on Google. 1 million people log on to Facebook. 4.5 million videos are watched on YouTube. 188 million emails. A lot of data. So, how do you classify any data as big data? This is possible with the concept of 5 V's: volume, velocity, variety, veracity, and value. Let us understand this with an example from the healthcare industry. Hospitals and clinics across the world generate massive volumes of data. 2,314 exabytes of data are collected annually in the form of patient records and test results. All this data is generated at a very high speed, which attributes to the velocity of big data. Variety refers to the various data types, such as structured, semi-structured, and unstructured data. Examples include Excel records, log files, and X-ray images. Accuracy and trustworthiness of the generated data is termed as veracity. Analyzing all this data will benefit the medical sector by enabling faster disease detection, better treatment, and reduced cost. This is known as the value of big data. But how do we store and process this big data? To do this job, we have various frameworks such as Cassandra, Hadoop, and Spark. Let us take Hadoop as an example and see how Hadoop stores and processes big data. Hadoop uses a distributed file system known as Hadoop Distributed File System to store big data. If you have a huge file, your file will be broken down into smaller chunks and stored in various machines. Not only that, when you break the file, you also make copies of it, which goes into different nodes. This way you store your big data in a distributed way and make sure that even if one machine fails, your data is safe on another. MapReduce technique is used to process big data. A lengthy task A is broken into smaller tasks, B, C, and D. Now, instead of one machine, 3 machines take up each task and complete it in a parallel fashion and assemble the results at the end. Thanks to this, the processing becomes easy and fast. This is known as parallel processing. Now that we have stored and processed our big data, we can analyze this data for numerous applications. In games like Halo 3 and Call of Duty, designers analyze user data to understand at which stage most of the users pause, restart, or quit playing. This insight can help them rework on the storyline of the game and improve the user experience, which in turn reduces the customer churn rate. Similarly, big data also helped with disaster management during Hurricane Sandy in 2012. It was used to gain a better understanding of the storm's effect on the east coast of the U.S., and necessary measures were taken. It could predict the hurricane's landfall 5 days in advance, which wasn't possible earlier. These are some of the clear indications of how valuable big data can be once it is accurately processed and analyzed. So, here's a question for you. Which of the following statements is not correct about Hadoop Distributed File System, HDFS? A. HDFS is the storage layer of Hadoop. B. Data gets stored in a distributed manner in HDFS. C. HDFS performs parallel processing of data. D. Smaller chunks of data are stored on multiple data nodes in HDFS. Give it a thought and leave your answers in the comment section below. 3 lucky winners will receive Amazon gift vouchers. Now that you have learned what big data is, what do you think will be the most significant impact of big data in the future? Let us know in the comments below. If you enjoyed this video, it would only take a few seconds to like and share it. Also to subscribe to our channel if you haven't yet, and hit the bell icon to get instant notifications about our new content. Stay tuned and keep learning.
I think you appreciate big data now much more better. So it's clearer and it's much more easier now. All right, so let's get going. Okay, so like I said, we'll learn about the big data. So the environment include the Hadoop and all those things, the HDFS, MapReduce, among other things, right? The whole framework, we call that whole thing the Hadoop framework, right? Apache Hadoop framework. So we'll look at all of that. So for our first lecture, this is 76 slides in all. I've broken them down bit by bit so we can appreciate each one of them. So for our first part, we are learning about the basic concept. You've watched the video, so there's a bit of clarity now. So we'll first look at defining big data. We'll first define big data. We'll talk about the characteristics of big data. And then we understand big data databases, which is key for all the things we're going to do. And then we explain big data technologies. So that is for the first part of, so today and tomorrow, these are the things that we are focused on, okay? That's what we are largely focused on. And then next week, we'll also focus a little bit around, then we'll go deeper into the NoSQL part. Today, we'll go deeper into the RDBMS, or the Relational Database Management System part. All right. So what's the big data? Today, it's the backbone of everything that we see, even as AI, right? And it started somewhere in the 90s. Predates a little bit, but that time data was not that very big. Okay. So please try and mute yourself. Try and mute yourself, guys, when you get in. All right. Organizations like Google, Facebook, all of that, they are the first that encountered a lot of the things that we talk today about as big data. It wasn't really big data to them, right? Like I always put, it was basically they had a data problem. What's the data problem? I mean, anybody who has programmed and worked with softwares before and data, when data becomes very big, it's very difficult to run queries. It's so difficult. You run one small query and it takes a long time for the results to come out. So that is how it is, right? So at that point, Google and the rest, they needed to come together and see how they can be able to deal with this problem they have, where they have very large volumes of data. In fact, as of 2010 thereabouts, Facebook used to take delivery of almost about 1,000 servers daily just to store our pictures and stuff. That's 2009. I'm not talking about now. Now it's far worse. So you can imagine the size and the sheer volume of data that we consume, we create every day. Pictures, all of you, those of you on Instagram, WhatsApp status, you are recording videos, you are doing this, you are Snapchatting, you are taking this, all that gets stored somewhere. So always know that we are creating huge volumes of data, okay? But the reality is that these large size of data was not difficult, was not easy for them to store, especially at the cost, and most importantly, processing them was a big and a huge tax, okay? Now, over the years, there's not been a single definition of big data. So if you notice in the video, it's more based on the characteristics, not exact definition. Now, so, but basically when the data is large and complex, right, which the traditional data processing softwares, which we're talking about in terms of the relational database management systems, we will learn very soon. Then we indicate that we kind of are dealing with big data, but normally it's based on the characteristics of the data that we classify these things, okay? All right, so as definition for my PhD is into big data analytics. Exactly, so at that point there was no definition, so I synthesized a definition, which I believed captured the different dimensions. So one of the dimensions was, some were saying it's a cultural thing. Cultural because it's a myth, right? It's more of a myth, right? It's a myth in the sense that there is a belief that when I have large data, I'll get better results. But I'm sure Sadika is here. And in her MSc Business Data Analytics, with the work she did, one of the things realized is that it's not everything that relies on big data. I mean, not the big data, but the size of the data, if you want to get good results. For instance, how we treat malaria is how we treat malaria. Those are rules. You cannot generate it 100 times in different ways. It is the same as it is. So such we call them expert rule systems, right? Such expert rules will not require very large data. They are rules. You follow them as it is. There's nothing you can do about them. You didn't set them. They are the way things have been set. But they are very essential for working. However, if you want to catch somebody who is doing fraud in, let's say, health insurance claims, making fictitious claims, stuff like that, that one requires you learning from different ways by which people have been doing fraud. That one requires huge data. So it is a cultural thing. It's a technological thing. It's a scholarly phenomenon in the sense that different people in academia and stuff speak to it differently. I mean, now there are over 15 V's. Academics have had so many V's to it. I mean, if I show you, there are too many V's with big data now, right? Now, one of the essential things is that the 5 V's are what everybody really stands out a bit more, because that's the initial. It started with 3 V's, then became 5 V's. Okay, please, just a minute. Okay, now essential about this is the value that you get out of the data, right? And the intent of that value is to be able to create actionable insights, okay? And it's not only that, you may create value, but how do you keep that value sustained, okay? So all of that, and the myth that when you have large data, it means you get good insights. I don't think when you have large data, naturally you get good insights. It's a myth, because people, you may have the data is bad. So your idea of having very large data, I don't think really it's what it is. Let me give you a typical example, like I always put it. Switzerland has 8 point something million people, yet their GDP is $810 billion. Ghana has 33 million people, yet our GDP is 8 point something billion, right? Dollars. Sorry, 80 something billion. Whilst 8 million people are producing 800 and something billion, 33 million people are producing 80 billion. Does it make sense? Perhaps naturally, if you had a lot of people being together, they should produce more, they should do better. Is that not it? Unfortunately, that's not what is happening. So the idea that when you have large data, everything will be right, will be as it is, I think it is a myth, right? So that is what led me to combine all these to come up with a comprehensive definition. So that is that. I mean, over the years, it's been very difficult defining big data because I remember when I was doing my PhD, one professor at GIMPA who was visiting then came and I did a presentation. He asked me. So, because years ago, I remember coming to the university with my desktop. I used to put it in a check bag. My hard disk was 250 meg. I was the toast of Queen's Hall, right? And everybody is like, you have a wild machine, 250 meg, not giggle, 50 meg. Everybody was excited with it, right? Good. Fast forward, what is 250 meg today? I'm sure if I give all of you a pen drive of 250 meg, you will insult me. But those days, 16 meg, 4 meg, 8, I mean, all these things. I mean, then we went to the gigabytes, went to all these kind of things and stuff, and now terabytes and all these things, right? So the world has changed, and it has changed considerably. So he asked me, so was your 250 something big? I said, yes. Then he said, then big data is time relative. So depending on the time that you are looking at, your data can be big or small. So you see the whole dimension. For him, there is a time dimension to big data, which makes big data a bit, but the most important thing about all of it is that you gain value and insights out of it. That is the most important, whether it comes big, small, large, variety, velocity, veracity, whatever it is the value, the insights that you get. And that's what is driving AI now. And we enjoy AI because of the way it helps us, right? Okay. So I won't talk about this. We've all seen it over the years. There's been exponential growth in terms of the data. These are the characteristics that they were talking about, the V's of big data, the main 5, the size of the data, that is the volume, the speed at which the data is coming, okay? So it's important data comes near real time. If not real time, near real time, okay? It's very, very important if you want to make, because like I always put it in Ghana, I don't know if there's any auditor here. I think the audit service is one area which lacks technology and advancement a lot. I mean, how can we be in 2024 and then we are doing audit for 2021 or something? 3 years far. By the time whoever that you are seeking or whatever that you are seeking to block it is, they have actually advanced and have created more wild, sophisticated ways of dealing with the things you are talking about, right? And so the speed at which things do happen matters. The variety in terms of different data types, right? We have structured data, we have semi-structured and unstructured data. I don't need to go over that. You guys know that now. All right. Then the veracity, how, and I think this is very important. How much you can trust the data is more important than the size of the data, right? The variety, how much you can, the veracity, how much you can trust the data is important. It's more than important. If you garbage in computing, we say garbage in, garbage out. So that is very essential, okay? So those are the characteristics of data. Now, it's very important also to understand this, and that is where the big issue, the volume characteristics come. And I always find it very intriguing when the volume is mentioned. Now, let me ask you this. So you're going to look at databases shortly, and you realize something. MySQL is one of the databases that has very large, small size. So 1 million records of in MySQL may compose a size of maybe about may compose a size of about, let's say 10 meg, right? Which is very small, but it's 1 million records. 100,000 records in SQL Server, right? Or SQL Server is one of the databases, Microsoft's own, may have a size of, let's say 10 gig, right? Let me ask you, the 1 million records of data, which is 10 meg, and then the 100,000 records of data, which is 10 gig, which one is large? Let's debate. Which one is large? Which one is large? Abigail, give me your opinion. Abigail Aqua, I'm calling you. Abigail, are you there? If you're not there, I'll kick you out too, because it means you are not
Please,
listening.
I'm here. Stop, please, I'm here.
Which one is big? 1 million records in MySQL, which has a size of 10 meg, and then 100,000 records, the same records in SQL Server, which is also another database, which has a size of 10 gig. Which one is big?
The first one.
The 1 million
The
records.
1 million.
That is big. But the other one is not big. The 100,000, which is 10 gig.
It's also big, but the first one is big.
But the first one is big. Okay.
Yes, bigger.
It's bigger. So the size is not really the gigabytes, or is what? Richard, is the size the gigabytes, or is it the number of records? I'm asking you guys. Charlie, we're analytics guys. We're serious. Achu, is the size the because I Richard and muting guys? If I call you and you don't answer me, I'll just throw you out of the class, because it means you are not here to listen. Achu, are you here?
Yeah, Doc, I'm here.
What's your opinion?
To me, the size should be the gigabytes.
The large,
so the bigger one. So the bigger one in that size is the one for me.
The one for you. Okay.
Yes.
If I have 1 million records, 1 million records is 10 meg. I have the same records, so 100,000 of them is 10 gig. Now, if I'm giving this, which one will give me more insights? The 1 million records, or which is 10 meg, or the 100,000, which is 10 gig?
The 1 million record.
Okay, so the 1 million record holds more value than a. Now, if we take the characteristics of big data, what's the ultimate goal?
Is insight.
So 1 million at 10 meg is giving more insight than 100,000 at 10 gig. Is that not it?
Yes, that's what it is.
So which one is big data?
The one giving me the more insight.
Okay, what I want to put across is simple. That's why I said it's a myth. That's why in the definition I mentioned the myth perspective. Okay, I think most importantly is the insights you get out of the data. That is the most important thing. Whether it's big, whether it's large, whether it's in gigabytes, whether it's in records, is the insights. That's the most important thing. Okay, so it's not just mere the size of the data. That's very important. Okay, great, wonderful. Then we have the velocity. Now, the velocity basically talks about the speed at which these things come. And I've mentioned real time or near real time, okay? So in Africa, that's one of our biggest problem. Data coming in real time, right? It's very important. I mean, I'm on some projects which you see it's quite essential that you really need data in real time. It's very important. And data not sitting in silos, but connected. Because it's when the data gets connected that you're able to see, you are able to generate more insight because you can see different perspectives of the data, right? So that is the velocity perspective, okay? And it's very important. I mean, old news when it's old is dead. News that's why the media people want to break news even when they've not cross-checked, because it is then you can say that you are adding. You are on point. You are on point. Please, 1 minute. Guys, sorry, my wife is at the gate. Need to go up here. Okay. All right. Then we have the variety, and that for the variety, we've talked about it, right? So you know the different types, the structured, unstructured, the semi-structured, those three main things, right? Now, unstructured data holds more value normally than the structured, right? So we'll see how we store data when it's unstructured, especially semi-structured, right? We can also look at the pure unstructured, but they are stored similar in nature, right? Good. Then the veracity, making sure that, and that one, I think we've come across that when you're doing your Python, you came across missing data. When we're doing database visualization, we talked about missing data in your exercise. I intentionally made sure some data sets were kind of lost and missing. So you realize that having accurate data, having authentic data you can trust is very, very important when it comes to data analytics, especially big data, right? So you need to ensure that there are no inconsistencies or errors that are in your data largely, okay? So that you can get the kind of value you are seeking for from the data. Then the value, like I said, that is the most important thing, okay? So if you notice the one we watch, if I have health data, and let me give something like e-pharmacy that is currently rolling and ongoing. And I mean, they started the national rollout, and they've facilities they're working at. I mean, the joy I was learning from the project manager, the joy that comes on people's faces when they get text message of their prescription. Now, your prescription, there's nothing like writing physical prescriptions anymore. All your prescriptions become a code, right? So it's like a drug code, sort of. Once you have your code, any pharmacy, anywhere you walk to, they can retrieve your prescription. And I'm excited about it because it's typical, like if you've been to UK, the NHS is similar. Anywhere you go, anywhere, doctors don't write physical prescriptions anymore for you. It's all electronic. And once the prescription is generated, you can access it at any pharmacy in the country at any time in the way you want. If you want it delivered to your house, all those things are possible, which is going to open up a whole range of e-commerce so far as pharmaceutical services are concerned, right? And it will also save the doctors the time of always stamping and all these things. But the bigger value is the fact that, and that was one of the biggest things that I know led to the project itself. And the fact that we able to see which drugs and how much we've imported into the country, but we don't even know how it is consumed in the country. So, and that is very important. So if you don't understand how much, you understand what has come because of the ports, because the ports are digitized well, but you don't know how it's consumed on the ground. How do you plan for the country? How do you even know what the country needs in terms of a particular drug and stuff? And then analyzing the drug itself that is being consumed, it can give you patterns into disease profiles, patient journeys and stuff like that. Because the system basically links patient, health facility, the medical doctor or the health professionals, the pharmacist, and then the pharmacy itself. So you're able to see that whole thing. That typically in the old one, you can't actually even see which doctor give the person a prescription if a pharmacist is looking at it. But now you can link all the way to the doctor and stuff like that and follow the trail, right? And this allows you to be able to gain insight. And if this data is gathered across the whole country in real time, you can imagine the kind of insight, how much control our our health ministry and the rest can have over our health related data. Some people have died simply because they didn't know where a drug was, right? But with this system, they will be able to quickly know where a drug like that has popped up anywhere in the country, and they can actually quickly get a drug if they need to. Okay, so now let's look at some big data applications. We're going to look at a few of them. Big data is exciting. For me, it's exciting. So we have in healthcare, I've been mentioning a few, like the one that I'm talking about right now, the e-pharmacy thing. It's exciting. It's interesting. The Nigerians were here this week, trying to learn from how Ghana is rolling it. The Kenyans were here, I think, last year towards the end to learn how Ghana is doing it. And it's exciting. You go to Dubai and the rest. I've been to Dubai and the rest. It's there. They already have these things, right? And so it's very interesting. And the kind of sheer data, the volumes of it that comes, is interesting. We have big data in e-commerce. So let's take a look at it. Basically, if you look at it, it comes with different data. You're able to see different data. So we're able to, in the health facilities, we have LIMS, for instance, that's collecting the basic EHR data, right? And stuff. We have the e-pharmacy, which is linking across the country in terms of drugs consumption and stuff like that, right? You have research data from the institutions. You have different data, your fitness trackers. And I can imagine when it's well integrated, right? You can imagine that we can be able to monitor your I know they are trying to do telehealth too. If that comes on board, devices linking up and all those things will become something very interesting. It will give you a whole big perspective about your own health. Can you imagine waking up in the morning and the system recommending to you through an AI or something based on your pattern of how you set your sedentary life, and it's making recommendations, drink a glass of water, blah, 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 things like that. So that is how big data basically comes from a huge perspective in terms of health, right? Now, if you take, this is a typical example of some people trying to roll out that Cytostech, trying to do this for clinical analysis. If you have such data, if you combine, let's say, your diagnostic results and stuff like that, and it's coming in real time, the truth is that all these data I mentioned about, they will generate in very large volumes, but you can't process them in the large volumes. So normally, you have different frameworks that come into work. So we have Apache Spark. We'll talk about Apache Spark. Apache Spark allows for real-time streaming and processing. So you learn about batch processing of data and streaming processing of data very soon. So we're able to do those two and be able to analyze that, right? They are using Cloudera as a backbone in terms of the data issues. Then they have Impala and MapReduce queries. But we'll talk about the framework shortly, and you understand. Education. So in education, let's take KNUST. KNUST has a very good set of data in terms of our systems being very well connected. I guess if Mishro I don't know. Those of you who have been to other universities, how many universities have mobile apps that students use? Is there any university? I haven't seen any of them anyway, especially the big ones. Those who go to UG, are the UG guys here? University of Ghana, are you here? Saka?
Doc, Valley View has one.
Oh, that's interesting. Good. Okay, so that's exciting. What about biometric? Have you seen any anywhere? Anywhere you've seen biometric? So I like KNUST for the fact that we have different aspects of data that we feed, and that's a typical sense. When you have such data, the kind of analysis you can do. Recently, we did something on Pasty, and two other guys worked on. We use KNUST data. We try to follow supply chain students and then their profession. They've done a report on it. So they did a tracer study, but using the entire data, right? And following through that way. And it was very interesting with the insights that they had. Very exciting insights. Great. So in the education sector, there's so much that can be done, okay? There's so much that can, this is IBM's learning analytics, which is essential things about most of these things, most of these big data things. You just don't get up and then build a big data system. You need to sit down and look at what you need, how you put the different databases together. Please, it's you need to do something, you know, it just doesn't happen. It's not like your typical databases require you, or data, generally, if you're dealing with databases and insights, analytics, you need to sit down. I mean, if you notice the exercise you did, the biggest problem you had was not dragging and dropping the things there. Was the thinking, or is that not it, guys? Your experience, how was it?
Yes, sir.
Yes, even
That was it.
understanding the terminologies, which of the fields to use. Is that not it? You are confused.
We were.
And that's how real world data analytics is always is. They will not, nobody will come in. When they give you, when they give you a contract, they won't tell you, use this one, use that one. He has data sitting there. You have to decipher how you go around it. So you need to sit down on a drawing board, put pen and paper, try to shape your thoughts and your minds and how you about it. Because for them, they know you're a data analyst. And as a data analyst, you should be able to do magic. All they are waiting for is insights. What is the insight? How you got the insight? They don't care. Produce insights and let's go. So that is how it is. Okay, so most of these things have different, here they are using Apache Spark in here, right? So that's IBM Learning Analytics thing they did. This is big data in e-commerce. E-commerce, Amazon has one of the very interesting one, predicting and all these kind of stuff, focused demand. So you have different data that comes in, okay. And this is a typical use case that they have here, right? So you have the data clearly here, right? You have the users feeding in data. They have this, it's stored in an HDFS. HDFS, you learn from there, but we'll go into HDFS short very soon. So HDFS is Hadoop distributed file system, right? So it comes in there, it works with MapReduce. So we'll look at the Hadoop framework in a big Apache Hadoop framework, that's how we call it. Then you have the analytics and all those kind of stuff that come along with it. Okay, so this is somebody's own that they do have. We have big data in government, very exciting. And I always say I'm a fan of, forgive me, but that's my biases in terms of digitization. I'm a fan of the vice president in the sense that I love the fact that I think he sees the future more than most of the people around. The future is not this gorgeous big economy we've been in for ages and we are not seeing where we are going. It's time to transform and become more data-driven, more digital. I mean, you go to advanced countries and there is very few exchange of physical cash. Everything becomes electronic. Yet we are so busy, engrossed and fighting ourselves and still focusing on typical, I mean, you can't plan a country, you can't even plan for people you don't know. How do you plan for children born who you can't even identify? How do you do that? How do you plan? That's why Switzerland will produce 815 billion and we will produce 80 billion. Because their systems they don't have, things are integrated, everything is working. You kind of swear. Look, I remember UK Oyster cards, all these things. You don't even buy, we don't pay for transport with physical cash largely. Everything is electronic. You can plan your life. And these things make, and it helps the country to shift its mind from even if there's a thief in the country, the thief even has to think digital. He doesn't think digital, we have left him. The day you catch him as a thief, you can reform him if you have some good skill around that. Okay, so government, these are government kind of stuff. And this is a typical example where some things have been deployed. Okay, you have the government portals coming in, right? So in this case, you have something like in Ghana, you have something like Ghana.gov, right? The tax system coming in, you have NIA, you have e-pharmacy, you have LIMS, you have all manner of different DVLA. I mean, I was excited recently. I was doing some registration of a car with DVLA. Those of you after, it's electronic. They send you a text message. They want to even validate that it's you. They send you an OTP. I love the way the things are. It's changing. A time will come, you don't need to be physically present at different points for some things. And that's where the world is going. Look at Tesla. Look at Tesla. If you have a Tesla, I know a friend who has a Tesla in Ghana, brought his Tesla to Ghana. And when he has a fault or something, it's repaired electronically. I mean, everything it comes with this charging unit, blah, 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 stuff like that, right? It's a whole console. And when he's in Ghana, I have another military friend who, for him, he's in Ghana and he can actually start his car in the US. He doesn't need to be physically in the US to warm his car in the morning. Can you imagine? Look at how many of us travel. We leave our cars for 2 weeks. We come back and the battery is dead. Goodness me. When you can spark and warm the car every day from wherever you are sitting, whether you are in US or you are in Papua New Guinea or you are in Barbados or the Maldives, wherever you are, you can actually start and warm your car in the morning, check to see the car is fine, right? Look at the IoTs. Let me come to the IoT's perspective. I mean, today you can sit you can actually pick your phone if you have most of these IP cameras in your house, right? You can actually talk to your children. Nowadays, when I travel, I don't feel I'm so disconnected away from the family because I see what they are doing when they are playing football in front of the house, having whatever it is. They come back from school or something. I talk to them and they talk back to me because the cameras allow you to do that. You can talk to them, they talk back to you. You're able to see them. You're able to, in fact, when they arrive, the system sends you a message, they are in the house, that kind of stuff. You can talk, have one-on-one with them. And that is how big data in terms of a smart city comes to play. So you have different sensors, different things, sending information left, right, center, here and there. I mean, you can imagine. That's the kind of world that big data brings you up. But to do most of these require you to understand how, because data will be generated in very large volumes. And it's important you understand these things, okay? So that's what this lecture is basically about. Media and entertainment, advertising especially, right? It thrives on this. So this is a typical application also of big data because you want to ensure that, and Netflix is a very good example. I wish I would have shown you what Netflix does with our data. It's very exciting, the kind of things they do with our data. If you've noticed, you use Netflix and chill. So if you use Netflix, they're able to check to see the kind of thing you love, what you want to watch. They know I like Korean movies. They know I like Chinese series, stuff like that. So anytime there's a new Korean series or Chinese series, they'll throw it at my doorstep because they know that's what I like, right? And I mean, if any of you, when you log into your Netflix, right, you see that the things you love is what is aggregated around you in terms of what is presented to you, okay? Because they know that's where your interest is, right? So they are able to analyze your watching and all those things and be able to know these things and be able to say, okay, this video is best for you, right? And stuff like that. Be able to know when you stop, where you stopped watching, where you need to continue, things like that, right? So that's in the entertainment aspect, right? Okay, any questions, contributions, questions? We've gone through big data applications. Hey, maybe some question exam room. Maybe some there. Ajua Bofa. Yes, Achu.
Yeah, this is not a question, but I want to understand. You see, Ghana, we are believing in the digitalization drive and all that. And we have a lot of systems or websites. You mentioned
is it my internet or
Achu's? Anyways,
is it your internet or mine? The breaks. Can you guys hear me?
And we can hear you as well.
We can hear it as well.
Okay, I should go ahead.
Yeah, so I'm saying that we have the systems like you mentioned, data.gov and some other places that we can, use big data to do a lot of things. But when you go there, up-to-date data and stuffs are not there. And now that the digitalization drive is on the move,
You say
how
up to date.
are
Up
we,
to date.
those
What
of
is
us
not
learning
there?
these things?
I come up to date.
Up-to-date data. For example, if you go
Okay.
to data.gov, when you need let's even last year.
Go ahead.
Data, what are the those of us learning and those of you at the top of the system
So normally, actually, not to cut you, but normally I'll be very frank with you, okay? There is proprietary data, is public data. Okay. I think we're gradually getting there, but we are not there. There, in a sense that data interoperability is central. Okay. Systems talking to each other is central. But however, we are still at a point where people are scared to share data. I mean, they know they need the data. And so I think that maybe institutions like ours, KNUSC, have been thinking about it with Dr. Matilda for some time now, how we can create something from a research perspective and see how some of these data can be harnessed in real time and try to put them there. Form like associations, corporations, things that you contribute, you take some from me, you take some from this. If you are part of it, you're able to assess this. We also need government and parliament and all those people to support these initiatives. For me, that's sometimes where my biggest worry is. We fight so much among ourselves that we don't move forward. So we need, it is not, we're going to talk about strategy, big data strategy. It's a strategy issue. It's a strategy issue. It's a strategy issue. The citizens naturally don't understand some of these things, okay? And the organizations, even those who are manning sometimes, look at NIA, how long it took for NIA to become interoperable, for people to be able to connect to them. Even that one, which was being championed at that level. Recently, I've been on some projects and I think even the people there themselves don't even understand the fact that we need to connect. Everybody's looking at the money, everybody's looking at something, everybody wants to play a power game, that kind of stuff like that. It's a strategy thing. That's why if you notice the definition of big data, I guess, I say there's a cultural dimension to it. I'm telling you. And that is where I think we've not been able to unearth it. I think academia can play a role. And for me, I'm trying to look at how we can do that. It's very essential. It's very essential. And you see, if you take the open data sources, the open data kind of stuff, initiatives that they put up, they too are constrained. It's not their fault. That's what they also get. It's not they are looking for the data and somebody has given it to them. I mean, we are here sometimes even people looking for valid data from people where they go through even legal basis. Sometimes people don't get it. So the truth is that it's a cultural thing. We need to understand that. It's just like digitization. You talk about digitization, people carry it into a political realm instead of how it benefits everybody in the long run. Health data, for instance, if you're able to, one of the reasons why I'm passionate about health data is simple. My daddy almost died because his data was not available at a point in time. And for us, for me and my brothers, it became a wake-up call for us because the doctor clearly told us, look, John, if I use medicine to touch your data, your father, it was around 2 o'clock thereabouts, right? 2 o'clock. So if I touch him with the medicine, he would die. If I don't touch him with the medicine, he would die. If we wait for the lab results to come, he might be dead by then. I mean, you have 3 options of all dead, dead, dead. What would you do? Achu, what would you do? Mr. Achu, I'm asking you, in this circumstance, what would you do? Okay. So we had all of this at our doorstep, and that was something that forced us to go into a health information systems related company and stuff like that. And what saved my father was simply because the week before, the doctor who was looking after him and the other doctor and the doctor who has constantly looked after him, right, met a week before on an Ebola committee then. And so we said, oh, he said, yeah, I know him. Let me call him. Then he called the other doctor. The other doctor said, this is the nature of his kidney, so and so, blah, 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 blah. Give him this medicine at this dosage, so and so, so and so, so and so. When he gave to him, by 6 o'clock, my father was up sitting and drinking. In fact, he sent me, it was at Tech Hospital. He sent me, can you buy me, you know, the Milo drink, the can one? The man drank 2 to 3 at a go. I said, hey, this man has come to life. And it's simply because data was shared between the two of them. Salient, very important, relevant data. And for me, that was a wake-up call. The distance between life and death depends on information in the health sector. Look at how many of us are referred to health facilities, and you get there, it's like the labs are being done all over again. They don't even know what is wrong with you. Every doctor wants to find out for himself. Can you imagine if this data was being shared across all the time? I mean, can you imagine the lives that would be saved? I remember I was in the US during COVID time, I was under quarantine, and one professor in the US, and her mother is old, and her mother was almost at the point of death. And that day he came to the house, they were hosting us, he came to the house very worried. He said, John, my mother is not at a good place. You know, imagine COVID, your mother died, and you must come down. You know what I mean? It's a whole ball game altogether. The man was thinking, was visibly worried. And then he said, the doctor said that, if they're able to get a particular drug, but they've looked for the drug, they are not getting it. Luckily, I had built systems which cuts across the country, which gather real-time data on drug issues, health insurance claims. And I said, Prof, give me a minute. I went into the database, I queried, and the drug had popped up twice in the country at a particular specific places. Those who know Lighthouse Hospital, it had popped up there. And then the other place it had popped up recently was Techimanzongo. There's a pharmacy shop at Techimanzongo. That was where the drug had popped up. And immediately we saw that. I said, Prof, I found the drug. It popped up about 3 days ago in Techimanzongo. And then I called the rep who was in charge of that area. I said, go to that facility. Go and find out whether the drug. When he went, the drug was there. The man had it in stock. Somebody brought it from Abrochire to him. He's not even able to sell. And immediately they got the drug. They sent it. By the following day, the drug was in the woman was in Sefi. The drug was sent to Sefi also hospital, government hospital. They gave it to the woman, and the woman was well. In about 3 days, the woman was discharged to the house. And then I realized the professor had come down. In fact, he just think when the woman he came and said, John, your system is wild. Why can't we have it all over the country? But it is what let me put it, the people at the top saw it in action and said, can we scale this to e-pharmacy? That's how come the e-pharmacy thing came to be in the long run. So the distance between life and death, when you have these things, it's very important. So actually, I don't see a miracle anywhere, but I see we have to work towards the miracle to save this country. Yeah, we all need to work. I'm telling you the truth. I'm telling you the truth. There's no money. That's how the whites built their country. Or you think, how did they build it? The Wright brothers tried the airplane in different ways, they failed several times. Look at the bulb. Today, is the plane that you sit in the same as the Wright brothers when they did? Nancy, somebody had his hand. Nancy, go ahead.
Yes, Doc. You see, I'm listening to you and my mind is kind of running amok. Let's take a look at Netflix, for example. This company invested so much to, first of all, categorize all their movies and then develop algorithms that will serve the engines that work as the recommenders we see when we log on. But you see, Netflix is somebody's company. We can easily say they are motivated by profit.
Yes,
so
right.
then investing in these engines is like, it's core for them. It's their bloodline, it's their lifeline.
Sure.
But then looking at the government of Ghana, I mean, the benefits you are talking about, they are real. And they can even extend further than the things you are saying. But then how can our government, for example, get motivated enough to actually push these kind of drives? We are studying this program. Some of us actually want to do well in this course and then get to apply them in significant areas. But it's like getting people to actually understand, talk about funding, access to data, and those kind. It's like a full headache. You are already making strides in this line.
I can appreciate you, Nancy. I can appreciate what you are saying.
I don't know, volunteers, those kind of things. That's what I'm thinking about.
So that is why, if you remember the Accra people I talked to you, myself and Matt, we want to look at how we can, you see, we focus so much in our academia things on the degree and the knowledge. We want to look at the entrepreneurship side. Let me be frank with you. Most of these Netflix has a government portion. You have no idea. They do have them, right? You know, some movies are sponsored by the CIA and stuff. Do you know that?
I actually heard a theory on that.
Yeah, it's not a theory, it's real.
And that category has a full code that can take you directly to the
yes, and the US government gives budget purposely for those things. You see,
yeah, that's true.
The power of the media is it's powerful. Look at Nigerians. You go to Nigeria, anybody who has been to Nigeria, their power situation is far worse than we think, right? But when people see Nigeria, they see it with affluence, right? They see it with some. If you watch the movies, you think Nigeria is a heaven, right? But you go on the ground and Nigeria is
last night, my nephew thought Nigeria is better than Ghana. Yeah, our lights went out and he was like, "Oh, this doesn't happen in Nigeria." I was like, "What? You should go there and see."
Good. It's the movies. It's created an impression. You know, you always, whenever you see anything wild, you think it's the Americans who did it.
True.
If they didn't do it, you say it's the Americans.
True, it's very deep rooted.
Because they understand the value that comes with sending people's minds towards it's perception. It's a perception thing.
Yes, creating the perception.
Now, Nancy, I'll be very honest. I've been through this journey. I've seen it day in and day out. My wonderful MPhil student is here. We had to do some things this week with AI, and some of the things, honestly, I always put it, they seem very little, they seem very insignificant at the time you are doing it, but it has bigger implications. But Nancy, it won't come overnight. It comes by you starting something small. You are going to learn a few skills here. Start something small. Go to companies, go to entities, show them what you are able to do. Sometimes do things for free, okay? Sometimes do things for free. One day, people will recognize you and give you an opportunity.
I put it, I go to church not praying for wealth. I go to church praying for ideas. It's very important. Because if I can solve problems, money will follow me. Okay. And there are many people with problems. The point is they don't even know where to look out for people's solution. Right. So I'm not saying it is magic. All these people, they're big nations, it's the same thing they've done. When the Japanese created their first car, when Toyota created the first car, the Americans laughed at them. Yeah. Today, do you know the most sold car in America?
Toyota
RAV4, to be very specific. Toyota RAV4. That Toyota RAV4. Today, the Americans pride. In fact, they have become big. Toyota has become big that it has bought Lexus. You know, Lexus is an American company. They bought it. And so now Lexus and Toyota all belong to one company. The Chinese, look at TikTok. Who in God's name thought that they will jump out like that? But it needs to start from a point. I mean, there's no magic. There's no magic. I'm happy you guys are here today because when I came back from PhD, I decided that come what may, we will do this big data, this data analytic course. It must start from somewhere. Anything you want to do, and I can bet you, for us, we are around to support you. We will help you. My goal is that for the next 10 years, I want to see how I can support young people in these technology and data analytics space. 1 minute, please, guys. So guys, we will support you. We'll be around. We'll try to help. And we want to start seriously on the entrepreneurship side. I've had discussions with Dr. Matilda. This semester, we'll try and do a number of them. We want to look at inviting companies, showcasing them what you guys can do for them, right? We want to give a platform like that. We'll do it every year or once every semester, so that I think the second semester will be the best. By that time, you've learned a bit enough to do something, so that we can showcase you to companies that are interested in you for work, companies that are interested in products that you come up with, companies that want to engage you. We will try and do that. You know, the whites do this job fair, this career fair, things like that. That's how you expose your students to. Because sometimes companies even don't know you can do them. They don't know this exists, okay? They don't know these things exist. And honestly, it's simply because, like you said, they don't even understand you, right? So we're going to do that. We're going to expose a number of you to our students to that. We really want to do it this semester. We're going to organize our first one, invite companies that are interested in data analytics, want to see how their data. We will give you we'll try and ensure that you have works like that, which you can be able to show, and then show them what you can do, right? Let's see how it goes. It's not going to be it's not going to be a nice and smooth journey. It's going to be roller coaster. Okay, so moving on, we've talked so much. All this exciting, no, but the real work is not this. This was completed and is looking nice in concept. Let's get to the real work, the hands-on part. So we're going to start off this way. There are types of things used in big data. I'm sure you all know that, right? So we are stuff.
Now, the first one is structured data and normally is managed using relational databases, okay? Then the second is semi-structured data, which we've talked about. We use non-relational databases for that and unstructured to non-relational databases for that. Now, let's move on. Relational databases, they are the traditional databases that we know. I mean, you can't do without them. We have a lot of data that way too. So we can't do without them. It's essential. That's where most of the times you start your data issues from. Most organizations have a lot of relational database, not non-relational databases. They have non-data that can go into non-relational databases, but they've not digitized. A lot of them have not done that. So you still have a lot of paperwork in a lot of places. So it's a journey. It takes time. Kakra, like I put it. It doesn't happen overnight. It takes time. Okay, good. Beautiful. Maybe okay, you will get there. I think maybe I'll have a webinar where I invite those who work on the e-pharmacy to perhaps have a session with us. We can ask our questions and see how at that scaling level, the operational issues, the technological issues, the governance issues, stuff like that. We can have a nice session. They present one evening, and then we can talk about it, right? That I think will help so that you see in real. I mean, they've done good work right now. They've done good work in terms of linking up and stuff like that. They are rolling to 100 facilities now. And I think over 2,000, the last time, 2,279 pharmacies, over 50, that's about 59% of retail pharmacies in Ghana have signed up. I mean, so you're going to see a lot of adverts all over the place and stuff with time billboards and all that. They are rolling out. So they had to do the pilot and all these things, which takes time. You needed to get things right before you jump out there. Josh, go ahead. You wanted to ask or say something.
Yes, Doc. I was just wanted to add that in all this, the rolling out of the e-pharmacy and all, some of the stories you told are very vital in terms of creating an emotional connection for people. I mean, the nation as a whole. I think a lot of people respond to emotions more if everyone is on board with the stories that you are taught, what you are doing has helped. I think a lot of the time we usually focus on the technologies, and a lot of people don't understand how they work. We get excited about it and forget about how to communicate what we have done into the real lives of the people that we are trying to do it for. So I'm suggesting that maybe that can also be considered if no such thing already exists.
So from a rollout perspective, let me show you what they've done. We have separated the technological team from the media engagement team. All right.
Okay.
Because you see, we've exactly what you said. The technology people are not good at telling their stories, actually. The technical guys, they are not good at telling story. They are engine room guys. So you need somebody who can carve the story, tell it the way it has the emotions hitting right at that point. So simple, so straightforward. In fact, when we started, it was a mobile app, more or less. But now we have even a shortcode to it. So even when you don't have internet, you still can have your prescription electronically because it comes as a text message, right? And you can use shortcodes to access. I mean, because and it happened after the pilot, when they wanted to do the first facility, all these things were seen. And so they had to hold. They actually had to pause like 2-3 weeks, just making sure that everything at that point is right. I mean, guys, strategy is important. How you go about these things. It's not just the technology. Technology there is the easiest you can deal with. But dealing with the things you're talking about, very, very important. Very important, very important. Even how to roll out so that it doesn't look political. Even that one is a bigger challenge. You know, look at the benefit I'm talking about. It has nothing got to do with politics, but we are there. So how you coin and carve the story and let it run, right? And it's important. I mean, we'll talk about strategy when we get there. You see, strategy is very important, guys. Very important. Very important. Strategy is important. Okay, so let's move on. Let's move on. 1 minute. Okay, guys, sorry I'm in the house, so sometimes family moves in and out. All right. Now, so we have relational databases. Okay, so we're going to first start with relational database, and Sadika will take you tutorials for relational databases. Please, he's not there to teach. He's there to help you in terms of the relational, the hands-on. So don't go and ask him what is the definition for big data. That's not why she's there for you. She's here to deal with the hands-on aspect. That's why she says tutorials, please, tutorials. So please, don't bother her too much with. She can assist you, but she's focusing on the hands-on. That's what she's here for. All right. So the relational databases, right? Those are the traditional ones. We know there are a number of them. There are many over there. Then we have the non-relational databases. They handle the unstructured and the semi-structured. Okay. They use what we call NoSQL. We normally call it a NoSQL. Okay. Right. Or not SQL. It's actually not SQL, NOT and SQL, but we say NoSQL. That's how we normally call it. Okay. There are 4 types of them. We have key value store databases, sort of. We have document store databases, column-oriented stores, and we'll go into them later. For starters, we'll begin with the relational ones, right? Now, the relational ones use what we call SQL, structured query language, or sometimes we say SQL, right? So you're going to learn about SQL and querying databases and stuff like that. They rely basically on relationship between the various tables, and we will look at them shortly. Okay? I mean, you guys should understand the relationship mapping thing easily. You remember we did the data modeling. Hello, in visualization, you remember the relationships?
Yes, Doc.
It's a similar thing. It's the same kind of thing. So those tables rely on one data related to the other so they can talk to each other, right? That's how it works. But we use SQL language to be able to query the data. So if you want to insert records into a table in the data, that is why you use some statements. If you want to update the records, you want to delete the records, you want to select from them, you use the SQL thing to do that. So we're going to learn that, okay? Please, it doesn't come by anything, it comes by practice, okay? I'm going to share the data we'll be working with. I'm using W3 Schools to do the teaching, the hands-on teaching, because W3 Schools is something you can always go back to. But if you want to, there are many others which you can. Let me see what I'm sharing. Now at this point, let me share my entire screen. Hold on. W3 Schools. Okay, you can type W Schools through MySQL. When you click, you get this. Yesterday, their site was producing an error. Let me see whether they've corrected themselves. If it's still the error as it is, let me see. Okay, they are getting errors in their thing. So, but I've tried to generate the data that they are using similar for you to use in your Navicat. So I'm going to share the data in your WhatsApp group. 1 minute, just a minute. We are using a SQL data, a simple Excel data, so that we can work with it. 1 minute, just a minute. So I'm dropping it in the WhatsApp so you can download. I'll put it also in the chat for you. Just a minute, 1 minute, analytics. Okay. Okay, so I've sent it over to your page. Let me put it in the chat also for you. Let me attach it in the chat for you. The attached file is here on my computer. Okay. All right, so I've sent it through the chat. So please, everybody download it. Pick the data set. Okay, wonderful. Okay, so that said, let me continue my lecture. I'll jump into the hands-on shortly. So you have structured query language, which is SQL, right? And we've mentioned some of the examples. We'll go through the various things associated with it. Now, how do those ones work? SQL databases or relational databases, they support what we call asset behavior of transactions. What do we mean by that? We have the asset simply means atomicity, consistency, isolation, and durability. Now, what basically happens is that when you execute a query, it is everything or nothing else. So you cannot have the query executed in part and not in the other. If something happens in part, then the transaction will fail. Okay. And while the transaction is happening, it must ensure that there is consistency in terms of how the data is related. So if I'm querying something which requires data from two tables linked as a result of the relationship that exists between them, I'm able to hit that. When it hits, that integrity between the two, the relationship between the two must be kept. Okay, so consistency is critical. Now, different queries, okay? Different queries will be executed. Let me put it this way. Like I execute my, okay, let me put it this way. That's a better way to put it. Now, when you are using a database, okay, or a particular table, and then I'm working on a particular record. Let's say, actually, let me use you, or Nancy, let me use you. Let's say I'm working on Nancy's big data data visualization examination record, that particular single record. Now, if two people are working on it, and I entered 54, I'm just making an assumption, or let's say 64 as your mark. At the same time I'm doing it, somebody is also, another person is working on it, and he is entering the mark 66. When we hit the enter key, the person whose own came last, even if it's 0.0001 seconds, his will be the one that will finally stay. It doesn't mean mine didn't work. The 64 I did not work. It did, but the other one has overridden it. So it's the queries are arranged in order. Do you understand my point? One after the other, and one does not interfere with the other. Hello, though we are all working, but my query went differently. Your query went differently. Okay, and that's the implication. All valid were executed until completed in the order they were submitted for processing. So one after the other. Do you understand me? Okay, great. Wonderful. Now, and then the last one is durability. Once you write it there, it stays as it is forever. And so that is the acidity concept when it comes to relational database and SQL. Okay. I'm moving further. However, no SQL uses a concept called base, right? DS is based, the data is basically available. It's in a soft state, and there is eventual consistency. Okay, right. We'll take, I don't want us to go into NoSQL now. We'll go into it deeper very soon. But for now, that's where this one comes. But basically, what it simply means is that NoSQL does not rely on relationships. No, it's not looking for consistency. It's not looking for the order in which somebody came. No. Okay. But ultimately, it ensures that at the end of the day, there is consistency. However, it doesn't base it based on a very hierarchical kind of thing. Okay. So it stores data based on like chunks, right? It carries it and puts it there. It doesn't identify that this data you brought in is let's say health data. No, it doesn't care about that. It doesn't have specific columns and fields like that. No, it doesn't come with that concept in mind. Not at all. The essential thing is that I had huge data. I want us to store them. I've broken them down into chunks.
Okay, that's why it says basically available and it's in a soft state, so that anytime I need it, they can make it available to me. That's it. But the processing of it itself does not happen at the storage level. It happens using parallel processing and those kind of things, the map reduce and all those kind of stuff, right? Okay. So we will get to that after we've dealt with the first part, which is the RDBMS and then the SQL that we use for. So now we're going to go into relational databases. We're going to learn a few concepts. But so what's relational database? I think you know that for now. I've talked too much about this, okay? It stores data in typical tables. So that's how structured data gets stored. And it's based on relationships, okay? So in teaching this, I would love to go hand in hand with with the practicals. Because if I just talk raw, by the time I'm done, all of you are confused. Those who have not done this will be confused. Even computer science people get confused all the time by the time you are done. So let me go bit by bit. Okay, so we're going to go with the MySQL approach. First of all, you've downloaded MariaDB, have you? Have you downloaded MariaDB?
Yes, please.
Have you installed it?
Yes,
Some
Doc.
of you, when you were installing, I was asking you for a password. You create your own password, please. It's your own password. There's nothing like a password. You can leave even the password blank if you want. But the root password is what is like the admin password of the entire database. Okay. So it's the heart. That's the password. That password, once it's compromised, everything about your data is compromised. Doesn't matter which other users are there. So when you are setting up, it's important. You can always reset the root password anyway. Okay, you can always, I say reset, you can always create a new one, right? If you've not set. Okay. Now, if you've installed that, so you need a database, but most databases don't come with an interface for you to query them. Like MariaDB, let me go to the MariaDB. MariaDB, so let me give the history of MariaDB. So this is it. Let me come from the small intro here. I like the Wikipedia one, which brings the history to bear. So I'm maximizing a bit. MariaDB is commercially supported. Please, what should I make? And that's the technical term actually. So MySQL, let me come first with MySQL, so you understand the history of MySQL. Let me see, maybe they may have the history here. Let me see. Okay. So Nancy, this story will be very good for you to understand. Then you realize it's not just government, even the private sector, it does happen.
Yes, Doc.
So MySQL, right, was created by a group of developers and was co-founded by this guy, Michael Windows. So the my part of the MySQL is her daughter's name. So anytime I mention MySQL, remember the my is actually her daughter's name, right? Okay. So one day when you create your own, you can use your wife's name to be there. So that is how MySQL was created. But after some time, the community became very big. I mean, MySQL was popular, and you know, Oracle is a huge database, right? But MySQL was giving Oracle a big challenge, a very big challenge. So the people in there, some of the people who were part of the whole thing that set it up, decided to sell it. So they sold it to Oracle. Oracle bought it. The idea, I guess, Oracle was to try and get them out of the market. If you can't beat them, you join them, right? Is that not it? The corporate world. So it does happen in the corporate world. Oracle just could not fight them. So Oracle bought them. And so they had an open source version of it, but the guys did not sleep. So the technical term is this word. So because it was open source, they altered it. They tweaked it into something which my Oracle cannot hold them for, because there's no quote unquote proprietary issues, right? So far as that is concerned. But the one the Oracle has bought now was under proprietary license, right? Good. So that is what they created as MariaDB. Okay, so that's the history of MariaDB. So after they did that, they also went in to create MariaDB. Okay, I mean, open source communities, some simply believe that you can't just keep everything to yourself. So Nancy, you realize even in America and all those places, they are going through this wahalo. It's not as straightforward. Yeah, but the level of it
But we
varies.
still appreciate the open source softwares that we get.
So we need movements like this in our country. We need them.
Yes, movements.
So and nobody is going to create these movements except me and you. And for the politicians, they have their own mind. Me and you, we have to create it. In fact, let's create it so that when you become popular, the politicians will look for you. You know, that's the truth.
Oh,
in
that's
America,
a
they
good
tell
idea.
people that the private sector actually controls government, not the other way.
Yes.
So we need to create those businesses. We need to create those wonderful things. And one of the things I'll put across is, please don't think Ghana. Think beyond Ghana. Ghana is too small. Your vision, MySQL, if they have just thought about America, they won't go. How would they have raveled Oracle if it's just there? You have to think beyond. You have to think Africa. You have to think global. So if you are building your products, the problem we have is most of us want to live in silos. That will not work. Forget it, brother. It just won't work. You can't make the money. You can't even make $1 million if you just think that way. So we need to think beyond, right? When you are doing these things, and don't think it's not possible. It's always possible. You start small, little by little, you arrive. Little by little, you arrive. I'm sure when they started this MySQL thing, Oracle was perhaps laughing at them. I've had, I don't know whether I've told you before, I've competed with Oracle before. We beat them to it. So it's not anything complicated. It's something that can be done. It's just a matter of believing in yourself, working one day at a time, step by step, bit by bit, you arrive. Okay? Please, 1 minute, guys. Okay, great, wonderful. Hey, the money was big. Do you see the money? No wonder some people sold it. They bought it at $1 billion. It's interesting. Okay, so you downloaded MariaDB, and so so when I say MariaDB is MySQL, you should understand me, right? Do you understand it now?
Yes, sir.
Okay, good. That is interesting. Let's move on. All right. So now taking a look. So you have this. If you pick the database, let me come here. Let me delete this thing here completely. Normally I try to go through first. All right. Now, when you start your Navicat, okay. First, the Navicat with the one you've installed, how many of you were able to crack it? Are you guys able to crack it? I put the crack in.
Yes, Doc.
Yeah. Okay, Nicholas, that's good. Please, if you are not able to, let me know, because I want to help you to do that so that it stays on your machine for a long time.
Please, I was not able to crack it. I'm using the free version, the try
Okay.
one.
So close it. Close your Navicat. Everybody, anybody who has not done it, just close your Navicat. Okay. Now, when you go to the file, if you open the file, there's a README file here. It gives the instructions over here. Okay. Can you see it? Can you guys see it?
Yes,
Yes,
please.
sir.
So you install the software. When you install it, there is a folder in there. When you open the x64, there's a folder called patch. You see this file. Do you see this file? You copy the
Yes.
file. You copy the file, and then you come to where you installed it. See program files. Sorry, I think it's the other one. Premium Navicat, premium soft. That's it. Premium soft, Navicat Premium 16, and inside the folder, you come and paste. So you come here, you come and paste. You right click, you paste, right? You paste. So you paste it there. But please make sure that you are not running your Navicat. Close your Navicat before you do this. Then you paste it. After you paste it, when you run your Navicat, it won't ask you any question anymore. That's it. Okay, so let me move on. And then make sure you do not install update. You go to tools, options, you uncheck this. You go to tools. I have done mine already. Tools, options. You see, check for updates on startup. Uncheck it so that it doesn't go and check and stuff. Because what you should work it. And I didn't to patch up. Men to know my home kwachiro. All right, good, beautiful. Okay. Have you been able to do that? This is a very simple thing to do. Have you done that?
Yes, Doc.
Okay, beautiful, lovely. Now, if you be able to do that, the next thing is to create what we call a connection. So if you run your Navicat, it will pop up. It won't ask you questions anymore. If you be able to do that, you come here, you see connections here. When you drop down connections, you see different types of databases it can connect to. So this Navicat Premium interface can connect to MySQL, PostgreSQL, Oracle, SQLite. SQLite is found in our browsers, okay? SQL Server, MariaDB, MongoDB. So we'll be using MySQL and then MongoDB, okay? We can connect to Amazon, AWS. So it can actually, these are cloud-related databases, the huge ones. So it can connect to them. Google Cloud, it can connect to Google Cloud. It can connect to Oracle Cloud, Microsoft Azure, MongoDB, Cloud Services or Atlas, Alibaba, Tencent, Huawei Cloud. So it can connect to so many things. I mean, this one interface, this thing I've given you is a very powerful tool. This one interface is very, very interesting. You can use it for many, many things. You got no idea, right? Good. So I've given you a very powerful tool which you use for the rest of your life. Okay, now that you've done that, you come to connections. Don't click on MySQL, click on MariaDB. Okay, you click on MariaDB. Then you give the connection a name. You give the connection a name. So maybe local MariaDB. I'm calling this way. Your root password, right? So if you didn't put any password, you can check that. When you finish, you can text the connection. Mine is deny access because it's expecting a password. So once you finish, you test the connection to see whether the connection is successful.
Is it working for you guys?
Yes, please, it's working.
Good.
No, please, can you go over again?
Okay, I'm going over. Connection, MariaDB. You click on it, it pops up. You give your connection a name. You can give it with, like the guy called it after her daughter. You can also call it after your girlfriend. That's your business. However you want to call it. Okay. If whilst you're setting up, you put a password, means you have to type that password here for your root. If you didn't put a password, you can go straight. But in all of it, just text the connection to see whether it's picking. Okay. In my case, it says that using password. So I didn't put a password, but it's expecting a password. So I type my password. Okay. And then I test my connection. My connection is successful. Once it's successful, I hit my OK button. So you will see it will join the connections here. You see local MariaDB. Have you seen it?
Yes. Yeah.
So if you've been able to do that, you double click it. When you double click it, will open and show the databases that are on your machine. Guys, just a minute.
Doing decent exposure. Bernard.
Okay, guys. So please, has everybody been able to do this? Is there anybody who has not been able to do this? If you're having challenge, let me know.
And Doc, I haven't been able to do it, but I'm on a Mac, so I'm still trying to figure it out. What
on a
happened
what?
was I had previously a MacBook,
Oh, okay.
and previously I had put in my SQL, and I was using Popsicle, but I'm trying to get the MariaDB on, but I forgot I had already installed the Xcode, and I've kind of messed it up, so I had to reset with the terminal, and I'm using the terminal to reset it and then download a new Xcode for it. So I'm a little bit behind.
Yeah, but
No, quite
okay.
sharp.
Okay, so in the absence of that, let me see. I still need you to work, so it's unfortunate these people, their own is not working. I think tutorial point should work. Let me see, do they have anywhere we can try? Let me see. Coming. Tutorial point doesn't have any interface for this. Java T point. Is that Java T point? So let's see where I can get
I just want somewhere you can try your hands whilst we are working. Okay, I'll look for something after the break.
Okay, Doc, I think maybe you can try programmers.
Which one?
Which
Programmers.
Programmers.
MIZ. No, programmers. So program MIZ. Not two M's, one MIZ.
This one. Okay, you have an online SQL editor here. Okay, good. Okay, yeah. Thank you, man. Okay, my dear. So we can learn from here, right?
All right,
The only
thank you
thing
so
is
much.
the tables and stuff might be a little bit different for you, but most of the times you get a lot of things similar, right? Because these have predefined tables in their system that we are working with, okay? Okay. All right. Let me see. Yeah, good. Okay, so I think can work with something from here. Okay. Okay, all right. So now that you set this up, we're going to go on break. When we come back, we jump into actual action, okay? All right. Any questions before we leave? Any questions? Okay, so please note that you'll be having a term paper also for this. I always want some hands-on. It's very important to me. All these theoretical talks plenty. If you don't produce something, you'll still be at the same point. All right, great. So let's meet 10:30, okay?
All right, thank you.
Bye, everybody.
Yes, sir.
See you. Okay, wonderful. All right, so where were we? Okay, so now let's go to our Navicat.
Hello,
Let me share the entire screen so I can switch easily.
Doc.
Yeah, can you? Yeah.
Oh, please, can I also record to support you?
No. Well, yes, sir. Obama system now, yeah, that's why I don't want. If everybody starts recording, the system will slow. That's why I want to. So when I finish, I'll share it. I'll send it to the class. I'll upload it to my Google Drive, and then you can share the link. You can pick. All right. So, all right. So now that we've done that, let's begin from the concepts. Now, the first thing is that the key concepts in a relational database is that you have to have a database. A database basically contains it's like a collection of tables, right? So you have different. It's like your Excel workbook, right? Your Excel workbook has different tables like that, right? So it's a similar thing, right? It's a similar thing. Okay. Now, when every table has columns and rows, right? Tables have columns and rows. And then, so you have the database, which is a collection of data items with some predefined relationships. So you have the relationships that come established. So the database consists of the tables, it consists of the relationships, it consists of the cardinalities of it. That's what we call the primary key and all those things, right? So that's the database itself. Now, if you take typically, let me come back to my Navicat. If you can see my Navicat, let me bring my, but you can see, right? You can see, so it's easy. I don't need to magnify. Or do I need to magnify?
This is a screen, so you should see. All right. So if you take here, for instance, if I open something like this, right? If I open something like this, you see the tables. This is a particular database with several tables, okay? In here. In here, you have, so these are tables. You can create what we call views. Views are like snapshots of the bigger table, okay? Hold on, the view I'm seeing here, let me come, hold on 1 minute. View, let me view it as a list. You can view it in different ways with using Navigator. So here I'm viewing as a list. I can view in this way. I can also view it from an ER or the relationship diagram that exists among the tables. I can also view it from that perspective. Okay, good, beautiful. But in this case, I want to view it from a list to make my life easier. Okay, so this is a typical list. Okay, good. So you have tables. You can have what we call views. Okay, so views are snapshots of the data. Okay, they are just snapshots of the data. Let me see. Hold on. Let me switch my Cloudflare on. I want to go into an actual database for you to see.
Good morning. You're not going this way.
Me too.
You're not going this way.
No, I'm going.
Yeah, please. Who is it? Actually, mute yourself. Okay, I think my Cloudflare is working now. Okay, so let me get this. All right, no worry, I hear you. So this is an actual database I'm trying to access over Cloudflare. So this is the database itself, right? So this is the raw set of tables. It contains a lot of tables. Okay, so about how many tables? Let me see how many tables there are. 388 tables. Some are duplicated stuff and stuff, but this is, in fact, this is the database that controls the entire Ghana Post, actually. So EMS going, parcels, everything. Those leaving the country come, everything. This is the database that controls it, actually. I built it in, I think, 2012, thereabouts, for them. Now, why I came to an actual database is that over here, you have what we call functions, okay? Let me see whether I can get, okay, this one is coming from function. SQL will show procedures. Okay, let me come from this one. Let me, so I can look at the design of the table itself. I want to come from the design of the table. If you take the raw design of the table, you have fields in it, okay? You have fields in it. The same vein, the one here, it's similar. We come to the object itself, and you have, let me take the users table here, click on design. I'm able to see the fields, okay? If there are any indexes and things like that, they are triggers. I wanted to show you triggers. So this one has 2 triggers. So there are many things you can learn from databases. So this is a typical trigger. This is a trigger that is written, okay? It's a typical trigger that is written, and then you have, and I mean, there are different things, okay? So these are triggers and stuff like that. Now, why did I bring you here? Because like I said, I want you to see that it's not just tables. It is more than tables, okay? It's not just tables, more than tables. That is why you have different types of SQL related things that we use to manipulate or manage it, right? So apart from the relationships, we use SQL language to be able to write certain things like the triggers you saw. We have what we call procedures, right? You can write procedures, stored procedures. You can write, we have to, even stored procedures, you have different. If you are using SQL, we have table valued functions. You have, you have different types, okay? Different ones of them. But I just want you to know that it's not just the tables and the columns and the rows. It's more than that. And it's not only the relationships, it's more than that. to that effect, we have different ways we classify the sort of things that we use to write the languages. Okay, so I've talked about tables. For columns, I think you know columns. I don't have to talk too much. You know columns. Rows, I think you know what a row is. Occasionally, we call rows tuple, right? Occasionally, we call rows tuples, right? So Oracle and the rest will call it tuple. So, and then we have an entity. So I'm coming to this part here, the entities. What is an entity? An entity, when we talk about it in data meta, is a representation of a real world object, okay? So for example, let's take you as students, right? So I'm trying to write a student information systems, okay? Okay, I want to do a student database. In the student database, you as a student, you are an entity. You are an entity. You as a student, you are an entity. Why are you an entity? Because there are several characteristics that are associated with you that we can describe. It's the characteristics that normally we put in the form of the columns, okay, or the fields, right? The characteristics is what we call the attributes, okay? Technically, that's how we call it, the attributes, okay? So normally columns are naturally attributes, but not all columns are attributes, but they are mostly attributes, right? Good. So a real world object is what we call that, okay? So you as a student, you're a real world object. A classroom is a real world object, okay? So if I'm doing a lecture timetable, a real object like a classroom has to be included, okay? Let's say courses, the courses you do is a real world object. It may look abstract, but it's a real world object, okay? Good. Real doesn't mean that you can always feel it, hold and feel it, no. That's not what it means. It means it's something that plays a critical role when the various things are interacting. That's a typical real world object. Okay, good. Then we have attributes. Okay, they give us more information and characteristics about. Yes, please. Go ahead, please. I'm listening. Who spoke? Okay. Okay, then every entity, normally most entities, we try to have what we call a primary key. The primary key helps us to uniquely identify each row in the table, okay? So if, let's say, I want to look into the students table and identify, let's say, Nancy here, right? Or Bernard or any one of you. What is the uniqueness about you? It's your student ID. Is that not it? That is what is very unique about you, because no two people have the same student ID in KNUST. So it is a unique identifier that we use in a database to identify a particular row in a table. Okay, so that is why we call that a primary key. It is unique. You can't have two of the same. Okay, so your choice of primary key normally depends on you and how you want to see it. Okay, great. So if you go to DVLA, your vehicle number is likely, your license number, your vehicle license number is likely to be unique. It has to be unique. You know, it's likely, it's unique. So you can use that as a primary key if you are dealing with cars in a DVLA database, for instance. Good. The chassis number, right? Or the VIN number, the vehicle identification, the chassis number is similar. Okay, then we have what we call foreign key relationships. You remember when we were doing when we did the visualization thing, we tried to establish relationship between the various tables. In relational database management systems, we call that foreign key relationships. Okay, so a foreign key is basically a key that links two tables. You remember we had the same thing here and here, and then it links up. Do you remember? Guys, do you remember that?
Yes, sir.
Yes, sir.
Yes.
So that's a typical foreign key. I didn't want to talk about foreign key at that time, but you see, Matthias, oh, when you go somewhere and they are saying a foreign key, primary key, those of you the computer science, I'm kind of more confused. is just simply one field or column is here, and the other field or column, and they link the two tables together. That is all. Nothing else, nothing more. So that's it. So normally you have the parent table and you have the child that comes and links up based on that, right? Good. Now, we have an entity relationship, okay? So the relationship between two different entities, okay? That is what we end up indicating is an entity relationship, okay? All right, great. And it's normally entity relationships are established using the foreign key relationship thing, right? Basically. All right, then based on it, we create what we call an entity relationship diagram. So like what Power BI created for us there in the modeling place, it's a typical ERD. So it's a similar thing, okay? In there, in an ERD, you have the entities that are there that are represented. You have the relationships that are existing between them. You have, I mean, many other things, especially more likely the relationships, and then that's what it basically is. Any questions before I move on? Okay, if you want to see a typical ERD, let me go to a typical ERD. So like the one we have here, let me have this one here. Let me come to this here. Let me view the ERD of this. Okay, they have this, but they are not showing any relationships. Okay, I'll show a typical one with relationships. They don't have any relationships established in between these ones that much. The other one is too big to show. This guy is too big to show. Console. One minute. Please stop playing. Please mute yourself. Mute yourself. Mute yourself, Stephen. I want to do this. Hold on. Guys, 1 minute. I have to stop my Navicat because that database is very huge. Very huge data, so. Hold on, guys. I should have clicked in ERD, that particular table, that particular database. Trying to slow the entire system down.
Close it down. Good, thank you. Because it contains almost about 388 tables, so you can imagine. You do that, we're in trouble. Okay, great, wonderful. Let's move on. Okay, so share the screen. Okay, so we have this here. Now, so this is what I showed you is a typical ER. This is easier to show. Tables are not many. Yeah, just a few of them. Not large size, not big too. So, okay, so this is a typical ERD, but this one doesn't have the relationships in there, right? It doesn't have the relationships in there. Okay. So to be able to play with the data itself, or to be able to create a database, to be able to create tables, to be able to, if you have a relational database management, to be able to create tables, to be able to select data from tables, to be able to update the records in the table, we use the structured query language, okay? So that's the language we use for manipulating. But we've tried to group these languages into different group categories so that we can actually say these are related to these are related to these, that is related to that, okay? So it's what we are going to do for the next few hours, and tomorrow it's going to be what we're going to be focused largely on. All right, good. So we're going to start off with the data definition language. So we have data definition languages, and the data definition languages basically help us to, they are the ones that define, they define the key characteristics that are related to the data. So I want to create a database itself. I want to create a table. I want to create a column, right? All these things, these are the characteristics or the things that are associated with the data itself, right? So that is what the data definition language related SQLs do. So we have them here. We have create, we have drop. Drop is used to, let's say I created something, I want to take it off. We say drop, right? Then we have alter. You want to modify something. You created a column, but want to change the column name, or the column has, it's able to only carry integers, but now you want to carry decimal points and stuff. So you alter. You can also use to truncate a table, okay? Truncate a table. So when you truncate, you are not dropping, right? But you are basically, it's like emptying the table, okay? So you can do that. So we have the data definition one. So these are some of it. Create, this command is used to create a database. So we're going to do it real. Drop, alter, truncate, we have comment, we have rename. There are so many of them, just that there are a few of them we have picked. So let's first deal with the creating ones, right? Now, to make our life easier, I know most of you will take a long time for you to arrive at this point. That is why I'm trying to use the navigations to teach. So let's look at the data definition ones, okay? Let me see. I have create here. These are the data definition ones. So you can create a database. So the syntax is create database so and so, right? You've seen that. So create database. So if I come to my Navicat here, the one that we are dealing with, the data I've given to you, we are calling it e-commerce, right? Is e-commerce, sorry. Let me down. This is a final, right? Good. So to be able to bring these things in, I first need to create my table, my database. So to be able to do that in Navicat, I'll come to MariaDB here. Click on it. And I either use the interface to create a table. Let me try to use the interface first. So I come here and I say, I'm creating a table called e-commerce. I give it a name.
The character set I will explain later, but you leave it for now. So you right click and then you click. You write the name. That's it. That's all. It has been created. Okay. Now, if I want to drop the database that I've created, I right click and I say delete. If you are using the interface, I understand, I delete. Now that I've done it this way, I am going to do it through the querying aspect. So on Navicat, after selecting MariaDB here, I click query. Then I click new query. So it gives me an interface to start typing. So here I'm going to say create. So you see that's auto completion. Create database e-commerce. If you want to, you can put a semicolon, and the semicolon allows you to say the next line is a different query. Then I run this. Okay. So I've run this. Now that I've run this, if I come to my MariaDB and I refresh, I have e-commerce here. So guys, you see, I was able to create this same e-commerce either from the interface or from the query. Please, it's very important, okay? So you can do that from both ends, either from the query or from that. So create is a typical one. Now I don't want this database anymore. I want to drop it. So I'll come and I say drop. So it has dropped it. If I refresh this, e-commerce is gone. So the same thing I did the other way, I've used the query to be able to achieve it. These are what we call the data definition related languages. So you have drop. I've shown you drop right now. So this is the syntax. You can look at it from here and practice. If you want to create a table, you can come here and then write create table, so and so. So you have the column name and then the data type for the column. So this is a typical example. Create table persons. You have person ID, which is an integer, last name, which is a variable with 25. So it means that this thing can take up to 255 characters, okay? First name can also take up to this, address, that kind of stuff. So this is how, so you have create table, the name of the table, you begin with the open, this is what, is it curve bracket or say curly bracket? This curve bracket, right? Or something like that. No, this is, okay, this is bracket, this is normal brackets. We have square bracket, curly bracket, curly bracket. Okay, so you do that, okay? You have that. All right. Remember, each column comes and then you have that. Now, today, and I'm sure Sadika will teach you that with it. Today, most of us, we don't think. Thank God for ChatGPT. Okay, I'm going to use ChatGPT. So I'm not expecting you to do any heavy lifting. If you have ChatGPT, if you don't subscribe to ChatGPT, to be good, though, that thing is a very important tool for your life as a programmer. Okay, so for now, if for instance, if I take this data, this table here, and we are going to try and do it. So let's say this table, I can pick the columns here at the top of the table. I'm going to create a customer table. I can come here and say, I tell chat, create a MySQL query. Guys, 1 minute, please. Just a minute.
Guys, sorry. Okay, so create a MySQL query for a table called customers, right? Having the following columns. Okay, so I come here and I paste my columns. Okay. Once I hit my enter key, or I keep my button here, we'll try and create a nice one for me like this. Okay, it's even added some inserting data kakra for me and other things. Okay, but I'm not interested in all these plain details. Okay, so it's created a table for you. Look at how it's created. Create table, customers, customer ID, customer name, contact name. So I gave it what the fields. I copied just the fields from the top of this and I pasted it, okay? So once it's done this, I can copy, please. Nowadays, we don't worry ourselves too much. You can copy. You come here. Already, oh, sorry, I've already dropped the table. So let me recreate the database. I've dropped it. So let me recreate the database called e-commerce. And then I create a database. So you first open the database and then you try to create, come under it, and then you do this. But please, if you want to run the query within the database, if you are using Navicat, okay, you have MariaDB, then the table you want to, the database you want to use, select it. If you don't do that, and you leave it blank like this, it will not know where exactly to go. But if you want to use that also in the query, you say use e-commerce. Okay, once you say use e-commerce, it understands you use this database. But normally, if you are using Navicat, you don't need to be doing that. Sorry. So I'm going to select e-commerce here like this. Once I have this, I run it. So I've run it, it's okay. When I come here and I look at the objects here, sorry, oh, I need a list, sorry. So you see table customers has been created. Guys, do you see that?
Yeah. Yes.
If you double click it, it will come. This is it. The table will open with the various columns and all of that. Okay, so that is an approach which you can use. So you can go on creating all the other tables, but somebody will say that that is a long shot, right? Okay, but I'm just showing you how you do these things, right? How you do them, so you can do that. If you want to be very sophisticated with this whole thing, you can just come here to, I can come to Navicat. So I can come to my ChatGPT, click on this, and I say create using MySQL. All right. A MySQL query to create the tables in the Excel attached. So you can come from this, from a perspective like this. It will analyze and try and bring the columns and all those kind of stuff like that, speak the tables. It's trying to analyze each one of them and come out with the various things for you. Yeah.
You looking at?
I'm teaching things. Guys, please one. Okay, so we'll be able to have
ChatGPT assist us to be able to write these queries quicker. Guys, I guess you see it. Do you see that?
Yes.
Yes, Doc.
So today, and Sadika is here, she uses it a lot. Sasa, are you here? It's my girl here.
Yes, Doc. I'm here.
Okay. So today we don't waste our time trying to write queries one. So guys, please, why? We kind of do this. Even this one, he has written the queries one, so you can copy and paste them gradually. But if you want, you can say put all the queries together. So I want everything in one big place, not separated, like this. Okay, so wonderful. So you can copy the code. I can come here. Let me drop this guy here. So to drop this, I'm deleting it. I understand I delete. Okay, I can come to my query here. Let me kill this guy. Now I copy and then paste this guy like this. How about this something also? When it's doing this, it's even creating the relationships for me. We'll come to the relationship shortly. Please note, it's trying to create relationships, foreign key and stuff like that. I'll go and create them specifically for you to understand. I'll drop them and create them again. But I just wanted to use it to show the entity relationship diagram that comes with it, okay? So you have this. Once I have this, I can run this. So I've run it, it's done. When I come here and I come to my table and I refresh, all my tables are here. Do you see the tables? Hello, guys.
Yes, Doc.
Yes. Is everybody okay with it?
Yes, sir.
Okay, beautiful, lovely. Now, if you have this, you can view now because I have relationships and the rest, it's easier to see from an ER diagram perspective. So this is a typical ER diagram perspective and stuff like that. Let me see, go. I'm just trying to arrange them nicely. So you see now it has established the same relationships just like what we had with the visualization one. I'm coming 1 minute. So, hello guys. So you've seen how it is, okay? Right. So it's just like the Navicat, the visualization one. When you click on this, it highlights this product ID. So it's showing where the relationship is. If you take this other details, where you see the yellow one, that is the primary key. However, where we have a foreign key, a primary key thing. So the product table here, normally foreign keys are created between one primary key here and then the other guy who is not likely a primary key at the other end. So if you take this product ID here is the primary key in the products table. However, in the other table, it is there, but at that point, we say that is the foreign key. So product ID in the other details is the foreign key, and it's referencing the product ID in the products. So if you go to the query we had, let's take a look at the query. Look at this, other details. Foreign key, product ID, references the product ID in products table. Do you see that? Guys, can you see that? How it's written?
Yes.
Foreign key in the product ID of the other table, because you're already on the other details table. So you don't need to mention it again. Foreign key on this references the primary key or whatever key it is in here in the products table. Are you getting me? So it's nothing complicated. It's a simple statement we write. So if you take this, can somebody explain this one to me? This one. Anybody, can you explain this guy, this one, this statement to me? Nimo Diana. Selma, help me. Auntie Selma, are you here?
Yes, sir. Please, I'm here.
Explain.
So the foreign key is the employee ID.
Mm-hmm.
And it can be found in, so please can you show the table?
Oh, you don't need to see the table. Oh. Let me show you something. You see, you are in the orders table. So basically, it means, you see, in the orders table, there is employee ID. So the employee ID here in the orders table is a foreign key, which references the employee ID in the employees table. So if you go to the employees table, you will see this is employees table. Where is employees table? You see employee ID is here as primary key.
Yes, sir.
Good. That is what it means.
Okay. Thank you.
All right. So please get these things in your head. Okay. Get this. Today we don't spend time thinking and writing these statements. Thank God for ChatGPT. But you need to understand what you have written, okay? Because that's the basis for it. If you don't understand it, then you have a problem. Good. Wonderful. Okay. Any questions, please? Ask your questions to. All right. I'll give you right now. Create your own. When I come back, I'll have one or two of you share your screen. I'm giving you 10 minutes for this. I'll get back at 11:30, 31. And then I want to see you have created your tables. After you created your tables, I'll show you how we bring data in. Yao, ask your question.
Okay, so I was wondering, is there a feature within Navicat that helps you to import the table rather than creating it?
That's the next step.
Oh, okay.
But the danger of that importing is that import will not create the relationships for you. Yeah,
oh,
what
okay.
That is why it is still important to create the table itself yourself. Because you understand the relationship. Normally, what it will do for you, and the danger of even that is that you see this one, customer ID, VARCHAR 10, description, text, birth of date, this is date, somewhere integers. You see the data types. We call these the data types, right?
Yeah.
You call these the data types. When you import, it's very difficult for other than you have to. What do you be important? You can import over here. Import I just a while to was selecting in a.
Oh, okay. Any auto detect.
Debbie. Some will try to detect, but most of the times, number of times he gets it wrong. One tell you if he doesn't understand, that's VARCHAR.
Oh, okay.
And if you don't take time, he will do VARCHAR 25542 for some of them. I don't. And you never appreciate it until your data size starts getting big. Because anytime you create a VARCHAR 255, you have created a space in your RAM or a space in your memory to cater for that on your hard disk. Because it's, you see, Well, if you just create them by heart without any sense, huh? Masa, at the end of the day, you are just increasing the size of your thing. Exactly. When you have just 100 records, 200 records, it's not a problem. But when you get 1 million, let me see whether the ones I have here, let me see whether the one I was looking here, let me see. Oh my goodness me, why did I go do this? Made in some Fubion. So let's take a table like this. Are you seeing this table? Can you see this table tracking?
Yes, sir.
Yeah.
How many records are there?
12
Oh,
million.
3 million. Oh, let me see, 1, 2,
That's 12
13.
million records, right?
Yeah.
And this is
Okay.
this is actually just 2 years of data. And this system started in 2012. This is just 2 years of data. So a number of the data have been archived. Imagine you had all this data in. We will be hitting hundreds of millions of records, right? And just this 12 million records, even this is MySQL, so it's better managed. The data itself, just the size of the data alone is 1.545 gig. The indexing we've done, you will learn indexing later on. The indexing we've done on it is bigger than even the data itself. Because if we don't have the indexing, you can't quickly query the data. Okay. So you appreciate why creating it from that point is better. Yeah.
Yes, sir.
I'm not speaking from theory. This is experience. I'm not speaking from talk. This is experience. So you need to be, you need to think through all that. That's why look at the size of it. That's why I was a bit worried when the ERD was trying to create itself, because it's such systems. You create ERD, so create ERD.
The whole year.
I mean, you can. ERDs grow, but really, that's why big data at a point, if you notice, at a point when you deal with big data, I mean, the thing has become big and you don't have time for all this academic nonsense. So you don't have time for this. When you're dealing with small data, it makes sense. But when you're dealing with very huge data, it's something else, brother. It's not as you think. Okay, good. Lovely.
Thanks, sir.
All right. Let me kill that. Let me close that connection before I start. So please I'm leaving you. Take a look at this, right? Try to create your own. When we come back, we do the import. 10 minutes. Christiana, ask your question before I leave.
Sir, Please, I'm a bit confused.
What's
To create, when you create the local MariaDB connection, and you create the e-commerce under it. When you select the e-commerce, do you need to add the table? Do you need to click on the add the table field on top of the screen, or
If
how
you
will you
want
go
to
about
add them, if you want to add them one by one, but I'm not encouraging you to do that.
Okay.
So what I'm asking you to do is you create a database and you click on query. Go to ChatGPT and try and create the query in the table in ChatGPT, like what I did. Have you seen that?
Yes, I've done that.
Then come and run the query. Okay, let me copy
Okay,
my.
so I'll click on query. I'll click on query before I do the
Exactly.
running.
You click on the
Okay.
on the database, then you click on query. Then when query comes, you click new query. They will open an interface for you where you can run your queries.
That I paste it and run it.
Exactly, madam.
Thank you. Thank you. Thank you.
Okay. All right, I'm leaving you 10 minutes practice. I'll come back. Why? Just a minute. I need to attend to somebody quickly. 10 minutes. 10, 15 minutes. I should be back. Thank you, guys. Okay, Sadika is Cesar. Cesar. Oh, she's dropped.
Yes, Doc.
Hey, you are here.
Yes, I'm here.
Hey, you are logged in as me. Anyway, all right. Okay, so Cesar, please,
Doc.
yeah, please be around with them 15 minutes in case anybody need assistance in trying the query issues. Let me make you a co-host, right? All right, so please practice. When we come back, we do the importation. Sadika is here to assist you if you need any assistance. Thank you. God bless. I'm stopping sharing, so Cesar can take over. All right, just give me 15 minutes. I have a guest who have come in. Let me just quickly. The person needs to go. Thank you.
Okay, hello everybody. How is it going, Sadika? How is it
Hello,
going?
Doc.
Ekosen?
I'm helping someone via the direct message. Nobody asked anything to.
Okay, that means that you guys are very fine, which is good for us.
Yes.
Okay, great, wonderful. Okay, so
Please,
now
sir,
that
I raised my hand.
okay, Christiana, go ahead. Christiana, go ahead.
Please, I raised my hand, but please, can I share my screen? After
Go.
running, I'm getting a message.
Hold
I
on.
raised my hand, no one was me.
Okay, go ahead. Share your screen, please.
Please, please, can you see it now?
It's now coming. Okay, we can see.
Yeah, this is the reply I got, like an error. I don't know if this is how it's supposed to be.
Look at what you've done. Okay, let's see where you copied this from. Where did you copy this from?
From chat.
Okay, let's go to chat.
Please, can you see it too?
No, you are sharing only the screen. So you have to share the chat one, the browser.
Okay.
So stop sharing
That
this
is
one.
how
Stop sharing this one and share
Okay.
that one.
Where is the chat? Yes.
It's a browser. So okay.
Please, can you see?
Yeah, but this is a table. Which table was it?
I copied all at once.
So let me see what you have. Where did you copy? I'm looking for that one.
Like
the customer table, the one you had there.
Yeah, I did it separately and I copied.
Yeah, but chat will keep. So scroll up. We should see it.
All at a go.
I'm saying scroll
Please,
up
can
where
you
you
see?
copied. Yeah, this is it. Oh.
Okay, please. Hey, yeah, Simon. We won't so cry. Are you confused?
Man, you're confused.
Okay, hey, it's here.
Okay, share now.
Where is it? Share screen. Share screen. This one. Oh, where's chat? Please, can you see it now?
Yeah, we can see. But what we are seeing is your client engagement thing. I'm saying, well, I know will come so be one check.
No. Azamba.
You have to share that particular one.
Don't
be
I'm
confused.
trying to share it, but it's not allowing me.
Okay, share your screen if it's possible. When you share your screen, then you can move to that place for us. It makes it easier. After you can unshare.
Okay.
If you don't have any strange things on your machine.
No.
I haven't said anything. I'm only saying that if you are comfortable, share. I want you to share for us, okay? I know your problem. I've seen the problem, but the problem comes from how you copy from chat. That's what I want to see.
Yes. Machine is to cry. When I try to let the title pick on something else.
Okay, you share something like the client. Okay, let me share mine. Come, hold on.
didn't cry no too.
Okay, so if you can see mine, when you do and chat writes the code, don't copy from the top here. You see here, copy code. Do you see it? You
Yes,
click on
sir.
that. That will copy only the code. So when I come here, come and paste this way. That's all. Okay?
Yes, sir.
That is the copying that created the proof. So you see, now share back your screen, the Navicat one. Share it back. Let me show you what. You copied another create statement at the top. Do you see you have two create? So you have to delete the first one.
Okay.
That was your prompt you gave to chat.
The
But
first one.
Yes, you have to delete the first line. You see, share your screen. Share your Navicat screen.
The Navicat, this one. Please, sir, can you see it now?
Yeah, it's come. You see at the top, you have created the customers table. But for now, what try and on your SQL query. Line one. It because that's what you
this one.
You copied it and added. And so he's seeing it as something which is a now run. I feel want to always say the same thing, create categories table. No, scroll down. Debbie, hey, madam, who delete and delete this? Who delete this? Delete control, scroll down. So create table, we create the categories table. And you're all broth into patch, no the circle. Scroll down, I'm sure you have more there. You see, you had create the employees table. It's patch delete.
Oh, thank you, sir.
Over to you, Jolate. So do that and then.
Thank you.
You can stop sharing, madam.
So I'm very grateful. Thank you. And sorry for.
When you finish, now, because you've already created the customer table, you can't start running the query from the customer one. You have to delete that the query for the customer table. It's table creation. Do you understand what I mean? Christiana, what American?
But I'm say, Mary name customer way no.
Debbie, rename. Opa, and I say a query into bet me I select ABC her. No delete. Now for categories from categories, no what run it. What you say?
Because yes. I've already done that one already.
Thank you. Exactly. I feel so at here. Good.
But that's why.
All right. Okay, so guys, that is wonderful. Is there anybody else with another problem? Okay, looks like you guys are good. Lovely. Now we have this. So now we have our tables here. So we're going to import our data. Now, when you come to the e-commerce, you select the e-commerce table, you go to import wizard. When you click on import wizard, you have a number of things you can do. So in this case, one import from an Excel sheet. Okay, just like Power BI. So you select the Excel here, you click next, look for the file. In this case, this guy. So it lists all the tables that are in the worksheets that are in the Excel. Then you can click, I'm selecting everything. So select all. If you don't want to, you can select specific tables you want to just bring them in, okay? But I'm selecting all. Then I go to next. Then here, field name is row 1. That means that whenever he gets it, the first field is the first row is the fields. Then the data begins from the second row. I mean, these things, you can leave them as defaults. So here you see it has tried to map my tables to the target tables because the names are similar, right? The names are similar. Okay, great. Now that we have this, I can then go ahead and say next.
So the next, this is where it's trying to map. So here it's picking, you can go table by table, drop down, look at it, see the names it has mapped. If you want to change the names or anything, you can do. Okay. All right. So yeah, go ahead. The last, go ahead.
Please,
The last, go ahead.
the import wizard. You at how you went about it.
I'm starting again. Click on the database. Import wizard.
Okay.
You seen it?
No.
Click on the database at the top here under objects.
Okay.
You will see import wizard.
I don't see it.
Hey. You click on the database e-commerce. At the top there, you see import wizard. Okay, if you can't see it, let me show you how you get it. Hold on. See whether there is anything here. No, that's the only place it is. Because that's the only place it is. Okay, can you share your screen? Let's see what you see.
Right.
Or click on tables, right click, and you see import wizard. Click on tables,
Yeah.
right click, import wizard. Okay, then Excel.
Right. Next.
The rest you can leave them. I mean, if you want to map differently, you can go ahead, but because we created the tables, it's easier now. So it's going to append the records, right? And then next, you hit start. So all the data has been imported. Have you seen the rows have increased? The rows are now there. So if I click other details, the table is here with the various records. You double click, please. When you double click, it will open the table. Or there's when I double click, it will open customers. Okay. Are we okay? Anybody with a challenge, let us know. Christiana, go ahead.
But when I was looking at your on the table, I saw the import wizard from your end, but I tried mine with the table and the database.
Have you
but I
opened
did not
your
see the
you have
import.
opened your e-commerce table?
Yes, sir. Just as I showed
Database. Okay.
you.
Now
That
here,
was where
right click. When you right click, go to click on tables. Tables under e-commerce. Right click. Do you see
I should
import
click on the
wizard?
tables. Right. Yeah, if you right click, you see it.
Okay, I mean shouting. Okay, so you are fine with that, guys. Okay, let me give you just a minute for all of you to import so I can continue. Let me bring my PowerPoint. Now we'll be able to do create and all that. We've done drop. So if it is a drop thing, the statement I showed you that, please we can refer to the statement. Drop table, whatever it is. When you click on it, you should see the relevant statements. Okay. If it's alter, this is the alter one. Alter table customers, add email to so and so. So here we are adding additional columns. So this is altering. So he has, if you look at W3 schools, alter table to add column, right? So alter table, the table name, add the column name, and then the data type.
You don't see your screen, oh.
You're not seeing my screen. Hey.
Yeah,
I'm sharing the Navica. Sorry, guys. Sorry. Okay. Yeah. So you have this. And if you come here, okay, let's go bit by bit.
Let me go bit by bit in terms of learning. So you have create database. I have a create database, you understand now, right? That's the syntax. Create database and the name of the database. Then we have dropped, if you want to drop the database, you can do it this way. You want to create table, is the tables we created. Now you understand create table, right? Do you understand create table? Okay.
Yes.
Yes. But you can also create a table from, but we haven't reached the modified ones, so the select and stuff. So I want to hold for now. So just the raw create table. You can create table from another table anyway. Then we have drop table. So you can drop a table, okay? So drop table, so, right? Truncate deletes the data inside the table, but not the table itself, like I said earlier on, right? Okay, so all these are DDLs. All these are what? DDLs. Data definition languages. Drop, create, alter, truncate, all that, right? Alter table, you can alter the table to add a column, can alter the table to drop a column, you can alter the table to modify the column. In this case, you want to modify either the name of the column or the data type, something like that. So you can do that. The examples here, you can try them out, okay? You can check them out. All right. So that is it for that site. Okay. Now, let's move on. That is the data definition languages. Okay, now we're going to the data query languages. Now we have our table, we have our data in, all of that and stuff. We want to be able to query the table. So let's look at a list of them. The first is select. Select means, okay, I want a portion of this data, or I want to be able to get the whole data. So you use select. There are a bit of syntax around it that we'll learn shortly. So we have select, let me mention them. We have, okay, we have select, but then we normally link them with data manipulation languages. So in here we have insert, update, delete, call, things like that. But the most important ones are the three at the top here. These ones, you learn them with time. You haven't started writing procedures. If you learn them, they'll become relevant. So we have insert. Okay, so remember the four things: select, insert, update, delete. But remember that select is a data query, whilst insert, update, and delete are data manipulation commands, right? Do you get me? Okay, let's explore each of them. Let's explore each of them in Navicat. We'll first go to W3 Schools because we're using W3 Schools to give us guidance. Okay, so here, select. So this is a typical select statement. Select. So in a select, you say select, can mention the various columns, the specific columns you want to select out of the table, or you can use star. When you use star, it means all the columns, bring them to me. Okay. So if we run our query, we should be able to get something like this. So let's try the select star. So let's try this guy here. Select star customers. Just copy. You can copy it. I'm going to run it in my query. Remember? So I can come and paste here, select star from customers. I ran, and it gives me the list of the results down there. So you've seen it. It selected 91 records in total. So that's select star. If you want specific columns, right, you can come here and you can put them here. If you like, there are two ways to write it. You can come and say customers dot, then it will bring the column names. I want customer ID,
customers dot customer ID and customer name, and then add the city in which the person is coming from. Okay, so if I run this, I will get just this. Okay, now, however, I can also come this way. I can remove the customers dot. The only reason I brought the customers dot is that I may not know all the column names. So when I have customers dot, it helps identify those columns and I can work with them. So you can write it raw like this. Okay, you can write it raw like this and then you run. It's the same effect. So I've shown that you use start and all the columns, can specify the specific column name that you want to appear. And so that is it, right? Any questions, please? Are there any questions? Okay. There are a few modifications you can do. So you can select distinct. When you say select distinct, it means that let's look at this data here. So here we had this, right? Interestingly, all these customers are different, but let me try something which we are likely to get multiple records in. Let me see. Okay. Okay, so let's go to customers, don't worry. So you see customer name. We have Odo supplies, right? Things like that. Okay. I want the distinct names that are in customer name. Okay. So I come here and I say, my select statement I had here. Let me use the select statement. Select distinct customer name from customers. So it's going to give me, instead of giving me all these customers, you give me just the names, Keke. So there are eight customer names uniquely. Okay. There are 8 customer names that are uniquely. So maybe the cities are just branches or something, but these are the 8 customer names. Okay, something like that. Good, beautiful. Just select the state. Okay, so you have seen that. We have we'll come here. These ones are here. Count and all these things are there. So if you say select count, then it will count the number itself. So if I put a count in front here, bring a bracket here, what will be the answer? It will give me the number 8 because there are 8 different customers because I'm counting them at this point. So that one you use the count. Okay, good. So you can work with that. All right. So that's select just raw. But apart from the count and all that, you can also have what we call, you can write your select statement and say where so and so. Okay. That means that you are selecting where blah, blah, blah. So for instance, if I take this data here, let's look at our customer data. I want all customers that are in Accra, only Accra. The city is Accra. So if I come here and I say select, okay, select star from customers, where city equals Accra. So this will give me only Accra customers. Okay, this will give me only Accra customers. Okay, are you okay, guys? Hope there is no confusion. Please, you or forever hold your peace. Okay, so that is that. You can combine different things, okay? This is where customer ID equals so and so. So you can, you see this is equal to Accra, okay? If it's actual numbers, you can actually play with it and see where so and so is greater than 20 or something like that, right? Good. Beautiful. So that's where. Still working with the select. Now, you can actually have conditional statements. So the ones, if you look at the where it becomes a condition that follows. So select so and so from table where condition. The condition is where the where comes, okay? What are you saying that should satisfy, based on it, should select for you? You can actually bring and, or, and not in your statements, okay? So if I take this particular one, for instance, let's try this. Select star from customers where I don't think this supposed thing is working. It's giving an error. Okay, let me see something. Okay, no problem. So now I come here. Let's try this. Where country is let's forget about country, because country is the same, right? Let me see from the table where I can join something. Okay, so you can use Navica to be easily filter. I'm trying to do filter here. I just want some data which I can get. So when you come to, after this thing has come here, you can actually, there's a filter thing at the top here. You click filter, this will come. Then you can click here. When you click, you can select exactly what you're looking for. Let's say I'm looking for supplier ID, supply ID 25. Okay, and I hit apply. So you have something like this, which works this way, okay? So let me see. These are products. Okay, let me use quantity per unit and then the product name. Okay, good. All right, so I'm going to write, let's say, select star from products where supplier ID is equal to maybe sub 025, I think so. That was what I saw. Is this guy? Okay, where's sub 025 and maybe category. Category IDs, let's say cat 001 or let's say 008. Okay, cat 008. So this is, you all know what AND is. You've done programming, so this one should know. So when I run it, this is the only one I get. So that's how you use the AND. Okay, you can say or means any one of them satisfied, it will show results. So it will show me all those that have sub 005 and those that have cat 008. Okay, it's like a union sort of between the two, right? Good, beautiful, lovely. Okay, so that's the end and all of that. Then we have the not. So the not negates whatever that you are talking about, the opposite of it. So like not that means it will bring me everything but minus cat 008 in the results. Okay, so that's a not. So order by. Order by. And these are very important. Select star from customer, order by country. Okay, good. Order by. So you can say if you leave it raw and you don't. So let's say order by. Let me try my Navicat. The same thing here. Order by category ID. So by default, it will be in this what is it? Ascending order, right? Good. But if you want it to be in descending order, then you have to be specific about it after the order by. And that would order it the other way around. Okay, good. Beautiful. You can order by several columns too. So the first column will come, then the following column will. So it's just like Excel and then sorting. It's the same thing. So here I want to order by category ID. When it's done, is you follow it by supplier ID. So when I run this way. So sorry, let me take the descendant off. So you have cat 001 all the way up to here. Here I have sub-0. So I ordered first by category ID and then by supplier ID. Okay, great, wonderful. Okay, so I think where I am, I don't want to begin this part. Let me leave this part. We'll come to it tomorrow. Tomorrow we'll spend time and try and finish the MySQL part. I think we are heading somewhere. All right, are there any questions? Let me allow for questions. Are there any questions, please? Any questions, please? Are there no questions? Hello, class. No questions?
No questions, no.
No.
Okay, go and sit down and enjoy it. Play with your, yeah.
Sir, when you were talking about the truncates, you mentioned that it was a DDL, but looking at the explanation, you said it clears the rows. It doesn't do anything to the table.
Yes.
And delete also clears the table. What means the delete DML and this one DDL? Like, I wanted to understand that part.
Okay, so you can't truncate a specific record. Delete, you can delete a specific record. So I can delete and have a conditional statement at the end. The moment you invoke truncate, everything in the table will go.
Oh, okay. Okay.
Do you understand? So normally when we want to empty a table, we say truncate. The technical term is we are truncating the table. You know what I mean? As Antiphobia say. So I cut it.
Okay. Okay.
But delete, I can have delete where this is this. But I can't come and say truncate where this is this. Do you understand my point?
Oh, yeah. So the truncate doesn't have like a condition where you can...
Truncate, it says empty the table.
Okay.
We don't have time to be dreaming and thinking about. You see, when you do delete, you see the 12 million records. The one you saw 12 million records. If I write a delete statement, it will go one by one trying to look for the specific records to delete. Imagine looking through 12 million records for specific records to delete. I mean, shall we? Are you getting my point? So delete can actually, so when I realize that I need to empty the table and maybe start afresh something, I just truncate and I feel I'm no big debate. So they don't even, it doesn't even look for the indexing in there or anything. It just clears, everything go. So that's why they say it's a data, it's at the definition level. Okay, it's not at a manipulation level. Delete, those ones can manipulate. But those truncate is not a manipulation matter. We are clearing it. We are clearing it, right? Okay, let me leave you guys. Please try and go through the W3 schools. Try and practice. This thing comes by practice. Guys, it comes by practice. There's no miracle around it. It comes by practice. So go and sit down. You've gotten all the tools. You've got your MariaDB. You've got your MySQL. You have got your Navicat. You've gotten wonderful tools today. The same tool is what we use for the MongoDB. That's the NoSQL. Okay. All right. So please try and practice. You will learn how to do a typical ERD, and I'm going to give that as an exercise. You do that, write tables, blah blah blah, whole database, things like that. You query and the rest. It's in batch your question because your 10 paper never. Your 10 paper, you do a bit of that and do a bit of the NoSQL. It's very important. Okay. I mean, shedding. Bye bye. Okay, Sadika, thank you. And catch you guys.
Welcome.
Okay, thank you, sir.
All right, bye.
Bye.